Good morning, everyone. Today, our group will present our final project to the application of trigonometry in the real measurement. Okay. For this project, we carried out field work around Uthm to measure real structure using trigonometric concept. Our main objectives were number one, point to apply trigonometric formulas to real structure. Point number two, objectives to analysis to accuracy of the measurement, and the last point to collaborate effectively as a team during data collection. Okay, now I would like to hand over to Raja Muhammad, who will explain our first field activity.
Activity 1. Height of building. For our first activity, we focus on finding the height of a building using the angle of elevation. We apply the formula height equal distance times tangent of the angle plus the observer height. This method allows up to estimate height without directly using the building. Calculation for activity 1. In this activity, we start 8 meter away from the building and measure an angle of elevation of 52.4 degrees. Using our formula, we calculate tangent of 52.4 degree multiplied by 8 equal 10.3 meter. So the estimate height of the building is 10.3 meter including the observer height.
Thank you, Raja. And the second activity was the measuring the slope angle of the ramp to check whatever is meet accessibility guidelines. For this activity, we use formula writing as tangent of theta equal rise divided by run. Our measurement for this activity were the rise was 0.31 meter and run was 1.5 meter. So, the calculation becomes tangent of theta equals 0.31 divided by 1.5. Then we calculate theta by taking the inverse tangent of 0.31 divided by 1.5. And the result is 11.7 degrees. Since the 11.7 degrees is lower than maximum recommended slope of 12 degrees, the ramp is considered to be accessible.
Okay, next I will explain activity 6, which involved using trigonometry and the shadow method to determine the height of a street light. In this activity, we use the concept of similar triangles. When sunlight shines, both the street light and our reference object create triangles with the same shape. Because of this, we can use ratio to find the unknown height. Before calculating, step 1 was to identify a street light and measure the light of its shadow. At the same time, we also measure our reference object, which in this case was a person named Raja, along with the light of his shadow. These measurements are important because the data we collected from both the street light and Raja will be used in the ration formula, and this information help us calculate the height accurately. For this method, we apply the ration formula. H1 over S1 equals H2 over S2. In this formula, H1 is the height of the light, S1 is the shadow light of the street light. H2 and S2 refer to the reference objects, which are the height of Raja and the light of his shadow. We use this formula because both objects for similar triangles under sunlight. For the calculation, we use the ration, and the data we get is straight light shadow is 115 inch. The reference object is 63.8 inch, and the Raja shadow is 42 inch. Okay, next we cross multiplied 115 times 63.8 equals 7337. Then we divided 7337 divided by 42 equals 174.7 inch. Finally, we convert inch to feet. 174.7 divided by 12 equals 14.6 feet. These activities show how trigonometry allows use to measure all objects safely and accurately just by using shadow and ration. That's all.
Field Activity 7 Angle of Hill. For our 7th activity, we measured the angle of hill slope using the vertical height and the horizontal distance. Okay, for calculation, our vertical change was 4.9 feet and our horizontal distance was 7 feet. To explain the calculation clearly, I will read it out. Our vertical change was 4.9 feet and our horizontal distance was 7 feet. Then we apply the tangent formula, tan theta equal 4.9 divided by 7. Next, theta equal tan inverse of 4.9 over 7. That gives us about 35 degrees. So the angle of the hill is around 35 degrees. During our fieldwork, we encountered a few sources of error. First, there was small inaccuracy when reading angles. The ground was also uneven, which affected our tape measurement. The shadow length kept changing, and the wind made our tool a bit unstable. On top of that, using phone-based measuring apps had its limitation. Despite all these challenges, our result was still consistent. Here are our final measurement. Reading height was 10.3 meter, ram angle was 11 and 7 degree, straight line height was 14 and 14.6 feet, hill angle was 35 degree. As we wrap up this project, we learned that teamwork is truly the heart of every success. Each of us brought different strengths, and by supporting one another, we were able to collect accurate results and overcome challenges together. This project also shows us that trigonometry isn't just something we learn in class. It's a tool we can use in real-life situations. Measuring height, slope, and shadow made the subject feel much more meaningful and practical. Overall, this experience helped us grow not only in our understanding of math, but also communication, trust, and cooperation. We were grateful for the effort and commitment from every member of group. Thank you for watching. Bye bye.